Hello everyone, let's discuss the direction of force between two current carrying conductors. So before the discussion of that concept, first we have to discuss the cross product between these two fingers. What is the resultant between these two cross product? So before that, we all know that the force is equals to I into dl cross B. So if we have a cross product between this dl vector and this magnetic field vector, obviously we are going to get the force. So let us assume this is magnetic flux density vector, like that this forefinger represents the direction of dl vector and the resultant, the thumb represents the resultant force vector. So between these two cross product we have theta. So at any case these three fingers should be displaced with respect to 90 degrees with each other. So these three fingers are right angles with respect to each other. So this is the cross product representation. So in this we have two conductors. In those two conductors we have a current. So based upon this current direction we have to calculate the direction of force. So first, current carrying in same direction, same direction. So let us having two conductors which are carrying the current in same direction. Before that we all know that whenever we have cross, whenever we have dot, current into the plane, like that whenever we have dot, current out of the plane. Clear? So here the current is out of the plane. So before that, what is right hand thumb rule? Right hand thumb rule. If thumb represents the direction of current, obviously fingers represents the direction of magnetic field, right? This is right hand thumb rule, vice versa. So here the current is out of the plane. So this is the representation of, let us say, thumb. Okay, let us say thumb. Obviously the fingers represents the direction of magnetic flux density. So this is out of the plane, the thumb represents the out of the plane. So obviously the fingers represents the direction of magnetic flux density. This is current, this is B, right? This is, let us say, B1, this is I1, B1. So obviously the direction of B1 is like this. Okay, so this is I2. Now here the second conductor is also having same current direction as of that conductor 1. So based upon this, what we have, the current direction is what? This is also like this, right? This is thumb. This is fingers. Clear? So what about B2? The direction of magnetic flux density due to the current in second conductor. This is what the direction of B2C. This is the direction of B2 due to I2. This is the direction of B1 due to I1. Clear? So like that we have current and magnetic flux density. So we have to get the direction of force between these two. So here the current is out of the plane, which is in the direction of dl, right? So current is out of the plane, that is dl. It is in the direction of dl, and see that the magnetic flux density is what? B1 is upward direction. The current is for example, if it is forefinger, this middle finger represents the direction of magnetic flux density. So the forefinger is in the direction of dl vector, like that the middle finger is in the direction of upward direction, obviously the resultant thumb. So from this, so this is what B, this is what dl, obviously the thumb represents what? Force. So from that we have to calculate the force of 1 on 2, the force of 1 on 2. So let us consider this is what? Thumb. B2 is what? Downward direction, and the current I1 is what? Is in direction of dl vector. So obviously like that I2 is out of the plane and coming to B1, which is nothing but upward direction. So by using right hand thumb rule, by using thumb we can get the direction of force, that is the direction of force is F12, which is the direction of force, that is where F12, which is nothing but force of 1 on 2, like that F21, force of 1, sorry, force of 2 on 1. So like that by using this I1 and B2 we are going to get the direction of force F21. So by using these two directions of forces we can conclude that the force is attractive, right? One is from left to right and another one is from right to left. So obviously the force is what? Attractive force. Force is attractive. So this is the one of the method to get the direction of force. Let us say this is method 1. Now I would like to explain the method 2. Okay, so like this we will get the direction of force. Now method 2. So before that first we have to write the cross product rule. Ax cap cross ay cap should be equals to az, right? Ay cap, sorry, cross az cap should be equals to ax, like that az cap cross ax cap should be equals to ay. Similarly, if we will get a negative value of az, ay cross ax should be equals to minus az, like that az cross ay should be equals to minus ax, like that ax cross az should be equals to minus ay cap, which is nothing but, let us consider three coordinate plane. Let us say this is x, this is y, obviously this is z. So what is the direction of x plane? Let us say this is minus x minus y minus z. So which is nothing but what? Let us say ax cap, this is ay cap, this is az cap. But coming to this negative x, which is nothing but minus ax cap, coming to this negative y minus ay cap, coming to this negative z minus az cap. So between these two, let us say ax, ay and az. So ax cross ay should be equals to az, like that az cross ax should be equals to ay. So between these two, ax cross ay should be equals to what? Az. So you will get the direction of force by using this formulas. Okay, so first let us say this is I1, this is I2, right? The current is out of the plane, obviously the magnetic flux density due to this I1 and due to this I2, we all know that, which is downward direction due to I2, which is upward direction due to I1, right? Clear? So this is what we all know, that this is B1, this is what? B2. So current is nothing but what? Current is out of the plane, right? Let us say x, y, z. Current is out of the plane, right? Which is nothing but what? Ax cap. So current is what? Ax cap. Coming to B1, sorry B2, this is I1, coming to B2, which is what? Downward direction. Downward direction is nothing but what? Opposite to z, that is minus z, right? Downward direction minus z, that is nothing but minus az cap. See here, x ordinate represents what? Positive value of ax cap. But coming to B2, which is downward direction, so which is nothing but minus z coordinate plane. If it is minus z, that is nothing but minus az cap. So we all know that ax cross minus az should be equals to what? Sorry, that is ax cross minus az, which is equals to what? We all know that az cross ax should be equals to ay, ax cross az should be equals to minus ay, but here ax cross minus az should be equals to what? Ay cap. So obviously the current, the force direction is what? Ay, which is nothing but positive direction of this direction. This is nothing but ay cap, right? So obviously what is the force direction? Which is this direction. See, this is what? F21. See, this is same as this coordinate plane y. So similarly, what about I2? I2 is what? Out of the plane. right, which is nothing but ax cap, clear. What about b1, which is upward direction? Upward direction is nothing but what? Az cap, which is nothing but az cap. This is ax cap, this is minus az, this is ax, clear. So what will happen to ax cross az should be equals to what? Minus ay. This is what? Minus ay cap. So obviously this is the direction of force of 1 on 2. So what is F21? F21. So from this method also, what is the force? Force is attractive. Force is attractive. What is the condition? When the two conductors carry current in same direction, they experiences attractive force. The force is attractive. So here the current is out of the plane. Let us consider the current is into the plane. Case 2. Current into the plane. This is I1, I2. Obviously the current is into the plane, which is represented by thumb. Obviously the the direction of magnetic flux density should be equals to like this, right? This is like this, downward direction. So because of this I1, the current is what? B1 is what? Downward direction, right? Downward direction. Like that, because of this I2, the current is what? Upward direction. Flux density is what? Upward direction, right? So x, y, z. So here current is into the plane. Obviously this is what? Minus ax cap, because into the plane means what? This direction, minus ax cap. So but coming to b2, which is az cap, same direction of this z, right? Coming to b1, minus az cap. Coming to I2, minus ax cap. So the force between I1 and b2 is what? That is minus ax cap cross az. The force between I2 and b1 is what? Minus ax cross minus az, which is nothing but what? Which is equals to minus ax cross az is nothing but what? Obviously ay, right? Ay. Obviously minus ax cross minus az should be equals to what? Minus ay. So what is the flux? Force direction? Minus ax cross az cap should be equals to what? Ay. This is what? F21. This is what? F12. So from this case also, here the current is out of the plane, means what? In both the conductors the current is same, right? When the current is in the same direction, obviously they experiences attractive force. So when it is out of the plane or into the plane, they experiences attractive force. Now in this case also, when the current is in the same direction, they experiences attractive force. Clear? Now we will discuss case 3. That is, one of the conductor into the plane and another conductor is out of the plane. Let us consider dot, let us consider cross. This is I1, this is I2. So what about the flux density, right? This is I1. Obviously because of this I1, the current is what? Like this. So here B1 is what? Like this. Clear? Coming to B2, Here the current is out into the plane because cross is there. So obviously this is also upward direction. See, because of the current direction, because this is also upward direction. So x, y, z, y, z, x. So current is what? Out of the plane. If it is out of the plane, we all know that out of the plane is nothing but what? Ax cap. Coming to B2, BT is what? Az cap, same direction of z. This is opposite direction or same direction of x. That's why positive value. So the resultant between Ax cross Az, right? Coming to I2, out of the plane. Out of the plane is nothing but what? Sorry, yeah, into the plane. Sorry, cross means into the plane. Obviously this is minus Ax cap. But coming to B1, this is same direction of z. That's why positive Az. So minus Ax cross Az, which is nothing but the direction of force. So Ax cross Az should be equals to minus Ay minus Ax cross Az. Obviously this is what? Ax Ay, right? So this is one of the force direction, this is another force direction. So which is nothing but what? Force of 2 on 1. This is what? F12. This is F21, this is F12. So like that you will get the direction of force. This is what? Out of the plane. This is also out of the plane because which is in the direction of Ay, which is in the direction of minus Ay. This is what? Minus Ay, right? This is what? F21. This is what? F12. Here the force is what? Repulsive force. So like that you will get the analysis for the case 4. What is the case 4? Cross dot. From this case also you will get repulsive force. This is homework for you. Simple, right? So what is the summary? When two conductors carry current in same direction, they experiences attractive force. And when they carry current in opposite direction, that is case 3. So same direction means what? Whether both current directions out of the plane or into the plane, but coming to opposite direction, one current direction is into the plane, another one is out of the plane, like that. So when they carry current in opposite direction, they experience repulsive force. The direction is what? Attractive force and repulsive force. This is about the force between two current carrying conductors in magnetic field. Like that you will get the direction of force. So method 2 is very appropriate method compared to, because that is entirely mathematical approach. If you know the cross product between two coordinates, you will get the third coordinate, that is nothing but force. Method 1 is what? By using right hand rule you will get the force direction. So by using method 1 or method 2 you will get the direction of force. Thank you.